Hey guys, this is questions 21 through 25 on the back of your study guide. So first up, we are finding the equivalent resistance of the circuit, and we are given a parallel circuit with 4 resistors. So you are going to use your parallel equivalent resistance formula, which is the inverse of each of them. So you would have 10 -1 plus 20 -1 plus 30 -1 plus 40 -1. And then you take the inverse of that. You can also type these in as fractions like 1 over 10 plus 1 over 20 plus 1 over 30 plus 1 over 40, and then take the inverse. It's up to you and your preference of what you want to type in your calculator. So anyway, you'll type all of that in, and you should get an answer of 4.8 ohms as your equivalent resistance for the circuit. So that's 21. For 22, you're filling in this chart. So you have resistance of 10, 20, 30, and 40, and then that total again is 4.8. All right, then you are given also a voltage of 24 volts for your total, and this is a parallel circuit. So in parallel, your voltage stays the same through each branch, so that's going to be 24 volts all the way down the column. All right, from there you can use Ohm's law, V equals IR, and you're going to solve for your current by dividing your voltage by your resistance. So we would have 24 divided by 10 would give you 2.4. 24 divided by 20 should give you 1.2. And then 24 divided by 30 would give you 0.8. And then 24 divided by 40 would give you 0.6. And then 24 divided by 4.8 will give you a total of 5. All right. So that's all we got to do for our parallel circuit. Next is we're going to take these same resistors but set them up in a series circuit, and you will have to do something like this on your test as well, using the appropriate symbols. So we're going to still have a 24 volt battery. I'm going to use the little squigglies to be my resistors, and you don't have to draw it exactly like mine is, but it needs to just have one path. Like if you put yours like all on one side, like if your resistors were all right here and there was none looping on this side, that's fine. As long as I see 4 resistors in one path, where this one has multiple, I need to see one path because that's what a series circuit is, and that's what I'm looking for. So now we want to find our new equivalent resistance. And with a series circuit, you're simply adding them together. So we're going to take each of our resistors of 10, 20, 30, and 40. All that stays the same. But now to add them together, it's just R1 plus R2 plus R3 plus R4. And that's going to equal our equivalent resistance. So when you add all of that together, you're going to get a total of 100 ohms. All right. Our voltage again is 24 volts for our total. And then we can find our current dividing by that 24 by that 100 to give us a current of 0.24 amps, and we got that using Ohm's law again. All right. So then, since this is a series circuit, our current stays the same this time instead of our voltage. So series is current is the same. So 0.24 will be all the way down that column. And then to find the voltage, you're just going to use Ohm's law again and multiply the resistance times your current, and that would give you 10 times 0.24 would be 2.4 volts. 20 times 0.24 would give you 4.8 volts. 30 times 0.24 is going to give you 7.2 volts. And then 40 times 0.24 is going to give you 9.6 volts. All right, so that's pretty easy. So the biggest takeaways from this to remember is you knowing which equivalent resistance formula to use, whether you've got series or parallel. That's a common mistake. And then also knowing what stays constant. So in a parallel circuit, your voltage stays the same. In a series circuit, your current stays the same. And that's a common mistake that a lot of students make. Otherwise, I feel y'all can probably do this without a problem. So let me know if you have any questions. Thanks for watching, I guess.